So we're ready now to actually go ahead and do a derivative, do all the analytical work of doing the limit and calculating the derivative. So this problem is asking to find the derivative by the limit definition, and the reason it's being stated like that is because in the future, most of the time that we do derivatives, we're not going to use the limit definition, but it is really important to look at it at first to remember where it's coming from. And when we have these nice little shortcut methods later on, which are great, but we have to realize that there's really limits going on behind the scene. So let's take a look at how we would do this. So I'm going to say f prime of x. Well, let's go back to the definition. The limit as h approaches 0, f of x plus h minus f of x over h. Okay, so that is our limit definition. So now what I'm going to do is basically apply that to this specific f. Okay, so the limit as h approaches 0, f of x plus h. Okay, what's being given to us is f of x. Okay, so f of x is 3x plus 2. F of x plus h would just be using x plus h for x as described in the original function. Remember, the original function is just a rule trying to describe what is being done to x. And so if you have something else inside, then you just do the same thing that's described from the original function. So it would be 3 times x plus h plus 2. Okay, so that's what I'm going to use here. 3 times x plus h plus 2. And I'm just going to put that in brackets here to make it clear that that is the first part, that is f of x plus h. Minus f of x. Well, f of x is just as the original function is described. 3x plus 2 over h. Okay, so again, let's be clear. F of x plus h is just this here in the brackets. F of x is just this here, and we're always subtracting them. And then we put these over h. Now, notice that, one thing I should have noticed is look at the derivative formula. If you were to put limit, try plugging in 0 for that limit, you would get 0 over 0. And the derivative is always giving you an indeterminate 0 over 0 originally. So we have to work out of it. So what we're going to do is just go ahead and algebraically work this out. So 3x plus 3h plus 2 distribute minus 3x minus 2 all over h. All right, so then notice 3x cancels with the minus 3x plus 2 minus 2, and we are left with 3h over h. Well, that's interesting because remember when we were doing limits before, when there were indeterminate 0 over 0 forms, we tried to get that factor that was causing the 0, 0 out so it could be canceled. Exactly the same thing here. H is going to 0, so the h over h is what is actually causing the 0 over 0. So we get the limit as h approaches 0 of 3, which is indeed just 3. And there we go. We just found that for this function, f of x equals 3x plus 2, we found f prime of x is 3. So it just so happens that this function has a constant derivative 3. Now that shouldn't be surprising because what are we looking at here? 3x plus 2 is just a line. Okay, so it's some line. And if we're asking what's the slope of this line at any point, slope of this graph, well, it's the slope of itself, because the line is the tangent line at every point. So the slope of the tangent line, the derivative, is actually, in this case, just going to be the slope of the line, and that's the 3 right there. So it's not surprising. Of course, we want to do something more, more general than that. So let's go to another example. All right, so let's now do it with f of x equals 2x squared plus x minus 1. Write that original f prime of x is the limit as h approaches 0, f of x plus h minus f of x over h. Okay. All right. So I apply the function. So remember, this is x plus h going in everywhere for x. So 2 times x plus h squared plus x plus h minus 1. So that's f of x plus h. Minus f of x is exactly how it's originally stated over h. And again, I just have to basically work this out. So x plus h squared in here would actually be x squared plus 2hx plus h squared, if you were to FOIL that out. So what I'm getting down here is 2 times that. So, oops, I forgot the limit. Don't forget the limit. Limit, h approaches 0. So I get 2 times this up here. So 2x squared plus 4hx plus 2h squared, and then I have plus x plus h minus 1. So that's all of the first brackets expanded. Minus 2x squared minus x plus 1 all over h. Okay, we see a bunch of canceling. 2x squared minus 2x squared plus x minus 1 plus 1. And so, keep going. See what's left. 4hx plus 2h squared plus h, and that's it, all over h. And notice again, what we're trying to do is, we start out in an indeterminate 0 of 0, so we're trying to get out the thing that's causing the 0 over 0, which is still the h over h. But I need an h from the numerator, but notice every term there has an h, so I could factor it out. 4x plus 2h plus 1, if I factor an h out of everything, all over h. Then cancel that out, get limit as h approaches 0, and I'm just left with 4x plus 2h plus 1. Now we're ready to evaluate our limit. But remember, this is the limit as h approaches 0, not x. H is the thing being taken in the limit here. So h here goes to 0, and any x's stay. So 4x is just still there. 2h goes to 0 because h goes to 0, and then plus 1 is still there. And there I have it. 4x plus 1. That is my derivative for this function. And notice now, the previous one was a new function. It happened to be a constant function. But now we see more clearly that this is a new function. And what it does is, whatever x value I plug in, it gives me the derivative value of the original function. Another way of saying that is, it gives me the slope of the tangent line to this curve at whatever x point I plug in. Now I have a lot of flexibility, so I can get the tangent line slope at any x value by just plugging it in here.